Hello and welcome to the walking talking topic, solving linear equations, question 6 with me, Mr. Barton. Now look what we've got here once again. It's a solving linear equations question disguised together with an angles question. So if you don't know all your angles facts, whether it be parallel lines or quadrilaterals as it is in this case, then it's really going to mess up your equations because you won't be able to access all the marks for solving equations because you won't even get to the right equation in the first place. So let's have a look what this is asking us to do. ABCD is a parallelogram. There it is there. All angles are measured in degrees. Nice. Find the size of BCD. Now where's BCD? That's B to C to D. So it's here. This is our ultimate goal, to find the size of this angle there. But we've got a few steps to go, and you'd expect so because there's 5 marks. Now the first thing you need to know is a little fact about parallelograms, and that's angles opposite each other in a parallelogram are equal to each other. And if you didn't know that, there's quite a nice way to show it, and I'll just show you quickly because I'm sad like this, I really like this. If I just extend those parallel lines and those parallel lines, you'll notice there that you've got a Z shape. And you know angles in Z shapes or alternate angles are equal to each other. But now look what we've got there, going across there and down there. We've got an F shape or corresponding angles. So that angle there is equal to that angle there, and that angle there is equal to that angle there, so these two angles must be the same. So that's going to be helpful, because if we can find the size of these angles, I'm pretty sure we can get that angle. So let's go for it. We know that 6x minus 25, that angle there, is exactly the same as this angle here, 3x plus 20. And now we've got an equation, and we've got ourselves 1 mark in fact. So let's see if we can solve this to find x. So first thing, I want to collect together my x's on the side that starts off with the most x's, which is this side. So I'm going to start by taking 3x off both sides. So I end up with 6x take 3x is 3x. I've still got my minus 25. My 3x's have gone from this side, so all that I'm left with is my 20. Now I'm going to add 25 to both sides. And I'm left with 3x, my minus 25 plus 25 disappears, and I've got 20 plus my 25, and that's going to give me 45. And finally, I'm going to divide both sides by 3, so I end up with x is 45 divided by 3, which I think is 15. Now, does that help me? Is that the answer to my question? Well, definitely not, because I need to work out this angle here. But let's use the fact that x is 15 to actually figure out the physical size of that angle. So it's 3x plus 20, but I know x is 15, so it's 3 lots of 15 plus 20, which I think 3 lots of 15 are 45, plus another 20 gives me 65 degrees. So that angle there must be 65 degrees. Now this is a test of whether you know another fact about parallel lines, and that's angles inside parallel lines aren't equal, but they add up to 180 degrees. Now some people call those allied angles or co-interior angles. Whatever you call them, you need to know that that angle there and that angle there is 180. And in fact, if I want to impress the examiner, I'll write this: angle ABC plus angle BCD must equal 180 degrees. And I know angle ABC is 65. I don't know what BCD is yet, but I will do in a second. So now if I want to find the size of BCD, I'm going to take 65 from both sides, so it's going to be equal to 180, take off 65, which is, if my math's right, which often it isn't, I'm going to go for 115 degrees. And I reckon I've got myself a well-earned 5 marks.